So what I was asking actually that what is that relation between congruency and similar? Congruency, all congruent triangles are similar. All congruent figures are similar. All congruent triangles are similar. But all similar figure, all similar triangle may not be congruent. May not be congruent. That one you have to keep in mind. So here you see exercise 6.1, all circles are congruent or similar. Definitely similar, because it will be congruent if radius are equal. Then all squares are similar or congruent. It will be similar because if sides are equal, then only it will be congruent. Otherwise, no. All triangles, all dashed triangles are similar. I already told. Isosceles are congruent because regular figures are similar. So it will be equilateral triangle. Two polygons of same number of the same number of sides are similar if their corresponding angles are equal. Number two, their corresponding sides are proportional. Corresponding sides are proportional. They actually ratio is supposed to be there, not given. Now two different examples of pair of similar figure. Two circles, two squares, two hexagon. Okay. Non-similar figure. Two isosceles triangle, two rhombus. Okay, they are non-similar figures. Then, whether the following quadrilaterals are similar or not? No, of course not, because one is rhombus and the square. Remember, according to the condition, if the two triangles are similar, their ratio of the sides should be proportional. Number two, their corresponding angles should be equal. Now here, rhombus, you see, angles are not equal, but square, all the angles are 90 degrees. So that's why they are not proportional. That is similar. Okay. Now next, very important property, that is the BPT theorem. Generally, we used to say BPT theorem. Okay. I'll draw the diagram. Now BPT theorem, and before we go to that theorem, try to understand. I'll draw the diagram, and at the same time I'll go and explain what we'll study here. Actually, in BPT full form is basic proportionality theorem. Basic proportionality theorem. Basic proportionality theorem. See, this is a triangle. The triangle A, B, C. This is the triangle. Now suppose D, E are the sides. You have to, if this parallel to the base, then AD by DB equal to AE by EC. This is the first. Or, actually this is the BPT theorem we have to do. This one actually asking. But apart from that, you will get other also. Now what is the use? Why you have to do that one? Because you see, by using this particular theorem, we can solve many questions. Suppose this side given, this side given, this side given, they are asking to find out this side. Then without basic proportionality theorem, you cannot do. So that is the reason basic proportionality theorem you have to know. Now, according to this, if AD by DB equal to AE by EC, then DE parallel to BC. DE parallel to BC. In the class 9, you got one theorem. If a line parallel to the base, if a line passing through the midpoints of two sides of a triangle is parallel to the base and half of the base. Now in continuation of that, this is another one. Now here also almost same, actually DE parallel to BC. That means AD by DB should be equal to AE by EC. In converse way, if AD by DB equal to AE by EC given, then you have to prove that DE parallel to BC. This is the basic proportionality theorem. Okay. Now, how we will do this one? Just use. Now, first of all, you tell me what is the formula for area of a triangle? What is the formula for area of a triangle? Area of a triangle formula is half into base into altitude. Half into base into altitude. Now, before I start that actual theorem, just I will ask you A, B, C. If I take altitude here, its area will be half into CD into AD. Yes or not? Yes? Okay. Now in the same, if I take instead of these, if I take this one, area of triangle ABC equal to half into BE equal into AC. That means whether you are taking BE or you are taking CD, area of triangle ABC remains same. Only we are changing the side, base and the altitude, nothing else. Okay. Now here, first of all, what you have to do, let ABC be a triangle. Let ABC be a triangle. D and E are the 2 points on AD and AC in such a way that DE parallel to BC. DE parallel to BC. Now last year you got one more theorem. The triangles stand on same base and within a same pair of parallel lines, then the area of the two triangles are equal. If you exclude this part, then you see triangle BDE and triangle CED stand on same base DE and DE parallel to BC. That means area of these two triangles are same. Yes or no? And this is the other triangle. Okay. So first of all, we have to write let ABC be a triangle. DE parallel to BC. DE parallel to BC. To prove AD by DB equal to AE by EC. To prove AD by DB equal to AE by EC. Now, do you remember how many parts generally in a theorem of maths, geometry? There are generally 4 parts. And out of the 4 parts, 1 part is optional, that is construction, as and when it is needed. Otherwise, interaction is compulsory, to prove is compulsory, main proof is compulsory. Only construction is optional, okay? So, okay, let it be. Then, next, we will come to the construction. From D, DM and from E, EN are drawn perpendicular on AE and AD. On AE and AD. Okay? Full stop. Then, BE and CD are joined. BE and CD are joined. Once again, from D and E, DM and EN are drawn perpendicular on AE and AD. AE and AD respectively. The next, B, E and C, D are joined. Clear? Then, see, now the main proof. So, area of triangle. Proof. AR within bracket triangle ADE equal to what? ADE. So half into DM into AE. Here AED equal to half into EN into AD. Got? This is the first one. Next, we have to write that what is the area of triangle? BDE. Area of triangle CED equal to what? Half CED. What is the altitude? Altitude is this one. So half N into EC. Now some of you may have a question that this is the triangle. Triangle is CED, and how it is at the altitude, because this is obtuse angle triangle. You know that in obtuse angle triangle altitudes are outside. Then AR, or the bracket triangle BCD, we get half into DM into what? So this is what? This is the altitude. Yes or no? I have done one mistake. Just a minute. So this is supposed to be DM. This is supposed to be DM. And this is supposed to be EN. DM, then EC, then EN into BD. Okay. So just a minor correction, so please don't mind, because you see, altitude will not come from, if you are considering the triangle the CED, then altitude is supposed to come from here, so it will be DM. Similarly, if you are considering a triangle BDE, so altitude is supposed to come from vertex. So that's the reason. Okay. So now, already I told, if two triangles stand on same base and within the same pair of parallel lines, then their area are equal. Now here you see DE parallel to BC, okay, and DE is the common base, common base. Therefore, triangle area of triangle CED equal to area of triangle BDE. Now next you see, just you do the reverse. Why you are doing the reverse, I will explain. BDE equal to 1 by AR triangle CED. Now this is invert angle, inverse. If they are equal, then their inverse will be also equal. 2 equal to 2, so 1 by 2 equal to 1 by 2. So this is also same. Then in the next line you see, if I write triangle BDE we are getting, no? BDE. So AED okay, AED divided by area of triangle ABDE equal to AR within bracket ADE triangle, AR within bracket triangle CED. Now, already I explained whether ADE or AED, it is remain same. There is no change. So there also no change. Now you substitute the value. Value of AED is how much? AED. AED is half into EN into AD. And BD how much? BDE. BCD. BCD. So wait 1 minute. CED, BCD, sorry, BCD, BC, BCD, BCD. So what is BCD? Half into EN into BD. So see, half EN cancel, AD by BD. Then the next side, ADE, half DM into AD. And CED is how much? Half DM into EC. So half DM cancel, AE by EC. So therefore, AD by DB equal to AE by EC. This is done. Equal. Clear? Once again, just you see once the triangle ADE and triangle AED are same, and triangle BDE and triangle CED are stand on same base and within the same pair of parallel lines, therefore their area are equal. And then if we take their area equal, their inverse will be also equal. And then we have multiply both sides, because you know in a fraction if you multiply two equal fractions by same number, then there will be no change. So as these are the equal fraction, we multiply by AED, and then we substitute the value, we get AD by DB equal to A by EC. Most important theorem. So please go through that and then please practice it. Okay, most important one. Okay, till then, bye bye.